Hello everyone and welcome back to another video. Today we're going to be diving in further into the Arista firewall configuration and management. Oops, sorry. Let's see if we can fix that blurring. There we go. So today we're going to be diving in deeper into the Arista next-gen firewall configuration, and on the list today is going to be DNS and DHCP. I won't go in depth how DHCP and DNS work because the general gist of the things that you need to understand is you can use DHCP to statically or dynamically assign IP addresses to a host, and you can use DNS to assign a human readable name for any computer that you might want to make easily identifiable in your network, be that a server or a host. Primarily, we're going to be working in the interfaces tab in the DNS server and the DHCP server tab of our generic Arista firewall. So if you guys remember in the last video, we spoke about just a general network interface, which is based off of VLAN 1, tagged and untagged VLANs. The beautiful thing about DHCP, which is also probably its drawback, is that it only works for tagged interfaces, which is VLAN from VLAN 2 to VLAN 4093. VLAN 4094 is just allow all VLANs, and VLAN 4095 is allow no VLANs whatsoever. And when you're doing multiple untagged VLANs, especially via route, like we did in the 5.5 video, sadly, you won't be able to use a DHCP server because it's not quote unquote an interface. And whenever you assign a alias to an interface, sadly, you won't be able to assign a DHCP server to that either. So for all intents and purposes, we're not going to address DHCP server and address management for additional untagged VLANs. We're just going to do it for a primary untagged VLAN, a primary VLAN. No, sorry, tongue twister. A primary untagged interface and a VLAN interface. As you guys can see, we have our wide area network interface, our local area network interface, and of course a VLAN interface. So how do we deal with VLAN interface? So let's select our internal interface. I see I still have the route, so I'm going to disable that real quick and I'll be right back. Alright, now that I got rid of the VLAN 3 route, let's go ahead and figure out how we're going to deal with the DHCP server on an untagged interface. So we'll take our local area network interface as an example, and we're going to go ahead and click on the little pencil over here that signifies edit. And we're going to go into the DHCP configuration setting, the DHCP configuration tab. Initially, it's going to be disabled because as a brand new interface, it doesn't have any settings. Well, you can click on both server or relay depending on how you have your network set up. For the purpose of this video, we're only going to be dealing with server. So we're going to click on server and we're going to give it a range, and it has to be within your scope. So as it is right now, the network is 192.168.2.0/24. So an address range between 192.168.2.100 and 2.200 is an acceptable scope, albeit a bit big, but whatever. That's another that's a discussion for another day. Now, obviously, you can give it a custom duration, and if you wanted to use a different interface or potentially a different netmask, and even a DNS, different DNS server configuration, you can do so in these three boxes respectively. Now, If you want to add any options like DHCP, bootp, or Pixie server information, you can always use the add button over here, and depending on how you want to set it, you can enable that option right here. But this is kind of beyond the scope of this video, as we're only going to be covering the basics. So once you have set your range, go ahead and click on done and click on save. Don't forget to click on save, it's very important. And we are going to mosey on over to the DHCP server side, which allows us to manipulate the different leases that we have assigned to our clients. So as you can see, inside of our DHCP server, we currently have two clients identified. One is going to be on our untagged interface, and one is going to be on our VLAN 5 tagged interface. As you can see, the DHCP server has correctly identified both on the two separate networks and correctly identified IP addresses within that range. Now, the manipulation here that you can do is essentially create and delete static entries, which is why I mentioned that you can create a static address via DHCP, although the name of the service is dynamic host. But if you set up a static lease, basically always binding one IP address to one MAC address, then no matter how many times that host connects or how many times that lease expires, it's always going to be the same address as the lease specifies. Now, if you leave it off and there is a conflict in IP addressing, the DHCP server obviously is going to try and resolve that. If not, you can intervene and manage that yourself. And that's pretty much it. Let's go ahead and create a lease. The easiest way to do it is you just click on the plus for add static, and voila, it's added. Or you can do it manually. Let's go ahead and just click on save. Or you can do it manually by clicking on the plus add right here in the top left corner, given the static address, or sorry, the MAC address, creating a static address that's within the range of the network and giving it a brief description. Now, another thing that you can do as well is you can click in the rectangular boxes over here so that you can go ahead and edit the details live as the lease is active. And as always, when you are done, don't forget to click on save to make sure that the effects are going to be active. So currently the two leases that we have is 192.168.2.116. We're going to leave that one like that. However, I do not like the fact that, for example, we do not have a round number on the 192.168.5 network. So I'm going to add a static lease, and I'm going to edit the IP address to be 5.100, and the description is going to write it down is client 2. Now, this description is for human information only. This is nothing to do, and it has no bearing with how the NGFW or any other computer on the network is going to understand it. It is specifically so you as a human, whether you are the network administrator or a network technician, who is going to read it and see, oh, okay, this is that computer right there, and do what you need to do with it. So like I said, I don't like that this address is ending in .84, so let's go ahead and reassign it to 5.100. Now I am going to go over to our Windows client, so client number 2. I'm going to open command prompt, and we're going to view IP config. Currently, as you guys can see, it is 5.84. So let's go ahead, release and renew, and if everything goes according to plan, it will pick up the 5.100 address that we have newly allocated it. And voila, it picks up 5.100 just like we set it up in our static lease. Now, the deleting is very easy. You just click on the little trash bin and you click on save, and that's it. It is deleted. Moving on to DNS. DNS is probably one of my more favorite subjects because it revolves a lot around of consistency and problem finding. One of the smallest lack of attention to detail means that your whole network goes in shambles. And if you guys are familiar with the fantastic meme, even when it's not DNS, it's still DNS, that's where it comes from. Because one tiny, I guess, misrepresentation in the DNS space, especially when it comes locally, and especially when it's an authoritative DNS server, essentially brings the whole network, can bring the whole network to a crawl, depending on how important that host is. So let's have some fun and mess around with DNS. Now, what is DNS? DNS is a service that allows you as a network administrator or as a network technician to assign names, or assign, depending on how you have the network set up, assign names or create a DNS relay entry for an authoritative DNS server, and then pass it on to your clients via DHCP. So if there's a little bit of an asterisk, if the authoritative server is still labeled as 192.168.1.1 or whatever is the IP of your NGFW. So let's go ahead and add a static entry. Now, as you can see, it's giving us a hostname.int and an IP address. Now, because I don't know it on top of my head, let's go ahead and give it this. And we are going to go under DNS server. And we're going to give this, and we are now going to assign it to IP address 192.168.5.100, and we are going to click on save. Not really, just giving you guys a heads up, I'm not really going to mess around in the domain DNS servers because I do not have one set up. This is going to be in a follow-up video, and I do apologize. This is still part of the DNS subject. However, believe me, it gets really deep and it's a huge rabbit hole that will have to get divvied up no matter what. So desktop-QKR-GOR8. So let's go ahead and, well, this is the, if I can get the DNS name. Oh, okay, fine. I want to play that game. So let's go ahead and identify this server. Look at that, desktop-QKR-GOR8. Now, realistically speaking, because your NGFW is also at the start of a network, your authoritative DNS server, if you do ping and then by the name desktop dot, oh, what's it called, QKR-GOR8, it should be responding. But I forget that with Windows clients, the firewalls are blocking the ping response. So hold on just a sec. We're going to disable firewall. It's a little disappointing where you have to turn off security features to make it work. So let's go ahead and try that again. Oh, as you can see, as soon as we took down the firewall, it started responding. And that's essentially what DNS does. It's It gives you the ability to assign a familiar and easily comprehensible name by a human being, whether it's a network administrator or a network technician, and it allows you to manipulate with it across the network. Now, let's say that for whatever reason, we decided to name, oops, sorry about that. Gonna delete that real quick. Sorry about that. Let's say that we decided to name that Windows machine just client 2. Now, realistically speaking, when I say ping client 2, because I'm already pointing to a specific IP address, even though it says it's from client 2, that's it's kind of like a relay. So the packet goes from your client to your NGFW. Your NGFW does a ping to the IP. If the IP responds, that's essentially how it is. But if you're trying to go ahead and use it as a service, let's see. No, I don't really have a service enabled on client 2. Actually, how would I be able to showcase that to you guys? Well, maybe I won't be able to showcase it. I'll have to think about it. But essentially, what's really important in the DNS part is that the name that you have in your DNS server needs to match the name that your client holds. So because I have named this client 2, let's see. Wow, it actually responds as such. Interesting. Okay, so never mind. But what I kind of wanted to say was, it's really important that the name inside of your DNS server needs to match exactly the name of the client that you're referencing, especially for services and especially for sensitive operations, like for example for databases. It's really important that what's on one end matches what's on the other end, and that's kind of a ongoing and forever true statement inside of PC networking and just PCs altogether. That being said, I do apologize that I couldn't showcase to you guys an error with DNS. I will find a way to showcase it and kind of give you guys information of what happens when there's a DNS mismatch, and I'm sure that you guys are going to enjoy seeing it in effect. That being said, thank you very much for following through with this little crash course of DHCP and DNS on Arista Firewall. I will see you guys in the next one.